Hey, what is up from 5? How are you doing today? Welcome back to our weekly class. Today we are going to finish chapter 5. Okay, today we are going to talk about vehicles in air. Okay, so we talked about Bernoulli's principle, Archimedes' principle last week. Okay, today we are going to talk about planes. Okay, planes and a very simple concept called Bernoulli's principle. Alright, so let's look at a plane. Okay, a plane has four forces acting on it. Think of it as four strings pulling on a plane. Okay, so you have up and down, left and right. Okay, so the down force is what we call weight. Okay, a plane has weight, or we call it gravitational force. Very simple. Okay, to make it go up, we have a lifting force. We call it lift. Okay, so lift and weight. Lift and weight, they are countering each other. Okay, so of course we have front and back. This is like your car. The going front one is called thrust. Your engine gives you the thrust, so you're thrust forward. Okay, so going forward you have resistance pulling you back. Okay, sometimes can be friction, sometimes can be air resistance. We just sum it up together as drag. Okay, drag. That's why a race going forward is called a drag race. Okay, I'm not sure you've heard of it. Okay, so drag race. So lift going up, weight going down, thrust forward, drag backward. I'm dragging you. Okay, so four forces. Okay, very simple. So lift, thrust, drag, weight. Okay, so an aircraft can fly when lift is larger than weight. Okay, if my lift is larger than weight, I go up. If my weight is larger than lift, I go down. Okay, something like your submarine. And then if the forward thrust is more than the drag, so if thrust is larger than drag, I go forward like your car. So if I let off the gas, I don't step on the pedal, now there's no more thrust. Drag is larger, so my car slows down. Okay, so simple. So therefore, the forces that enables aircraft to fly are lift and thrust. You need this too. Okay, so lift keeps them in the air, thrust moves it forward. Okay, simple. Okay, so we are going to talk a little bit about jet engine and rocket. Okay, these are two. We use the concept of momentum here. Okay, please write this down. You use momentum. Okay, remember what's momentum? Collision, poop, go backward. Okay, so now I don't want to look at the collision. I only want to look at this. Okay, when something pushes back, a force will push in front. Okay, this is basically momentum. Okay, so jet engine, they work the same way. Okay, so now the engine burns fuel and air. So I'm sure you've seen this. Okay, be on the wing of an airplane. Okay, so when the exhaust is pushed backward, it will push the plane forward. Momentum. Okay, so it's like collision, poop, they leave each other. Same thing here, but without the collision this time, they will do poop. Okay, air pushes backward, plane is pushed forward. It's just like how you roll your boat lah. When you roll backward, you push yourself forward. Roll, push. Okay, simple concept. So they use kerosene or paraffin, or sometimes you just use jet fuel lah. Okay, and then every jet produces thrust that push the aircraft forward. Okay, obtains oxygen from air. Okay, jet planes cannot fly outside the atmosphere. Okay, so they need air. Okay, so if you want to fly outside the atmosphere, we need rocket. Okay, rocket is the same thing. You have oxygen here, you have liquid nitrogen here. So when they add them together, it produces a huge thrust. Okay, it will thrust the spaceship forward. So next time when you see a space shuttle, okay, normally it will be attached to a rocket. Okay, so when it lifts off, and then after burning one chamber, the rocket will fall off, one more chamber fall off, one more chamber fall off, until the spaceship reaches the space. It escapes from gravity. Okay, so basically the same concept. Okay, so the higher the rocket goes, the greater its acceleration, because a lot of fuel and oxygen are used. The decreasing of mass, like I said, it will keep throwing away. After burning one side, one tube, it throws away, it becomes lighter. As rocket travels higher, gravitational force decrease, therefore acceleration increase. When you fly up, it's going to go faster and faster and faster. Okay, so what are the similarities? They move according to conservation of momentum, like I said just now. Okay, they use momentum. Okay, so difference, This is in the atmosphere, okay, of course, jet fuel. This is in space, okay. This uses kerosene or paraffin or jet fuel, okay. This uses hydrogen, okay. So oxygen is from the atmosphere, this is from storage. Quantity of fuel less, this is plenty. This is whole tube of fuel, okay. Usage can be used repeatedly, can be used once only. I'm just enough to push you out to space, that's it, okay. This part is not so common, so I wouldn't recommend you to focus. All right, let's go into Bernoulli's principle. This part is very, very, very important. No calculation here, only simple concept. Okay, Bernoulli principle states that the pressure in a moving fluid like liquid or gas, liquid is a fluid because it can flow, gas is a fluid because it can flow. So a moving fluid, a pressure is less, okay, than stationary fluid, okay, which means, oh, this is the summary lah. Faster speed, low pressure. High pressure, low speed. Velocity higher, pressure lower. Velocity lower, pressure higher. Okay, so it's here lah. The faster the fluid moves, the lower the pressure. The slower the fluid moves, the higher the pressure. Okay, so we use this in aircraft. Okay, this thing is called an aerofoil. Okay, our plane wings, they use this shape. Okay, can you see the aerofoil? Up there, it's smoother compared to down here. Okay, because it's slower here, this is smoother up there. So the velocity up there is higher, pressure is lower, it's reverse. Okay, like here, I said just now. Okay, so for the bottom, velocity is lower, pressure is higher. So what happens if there's a difference in pressure? High pressure will try to go to low pressure, so I will have a lift force. Okay, I will smoother, faster here, pressure lower, slower here, pressure higher, I will push my plane up. Okay, so basically this is how a plane and aerofoil works. Okay, so the flow of air faster at the top, slower at the bottom, so it creates a lift force. Okay, so basically this is how an airplane works. Okay, do you know an air spoiler? Okay, you know race car behind there's a very big wing. Okay, so it's the same concept, but I reverse the wing. Now I'm pushing my car downwards to create more grip, more traction on the road. That's why sports car has an air spoiler. Okay, that's the function of it. Okay, so Bernoulli's principle. So how do we show this? Okay, you will see this in questions a lot. Okay, let's say now I have a regular tube. Okay, I have a regular tube. I just flow water through. Can you see it's highest at X, lower at Y, lowest at Z? Why? This is highest pressure, this is lowest pressure. Why? Because the velocity here is the lowest. I'm only at the starting. At here, my velocity is like at the end, I accelerate all the way here. So the velocity here is higher, that's why pressure is lower, the water level is lower. Okay, so you can demonstrate this by using a paper. Like if I blow a paper, well, can you see it comes up? Because velocity here is higher, pressure is lower, pressure here is higher, I will push my paper up. Okay, Bernoulli's principle. Okay, so let's look at this thing. This is even more obvious. Can you see it is lowest pressure here? Because velocity here is the highest. This is the most narrow. And then the pressure is the highest here because it is at the beginning. Okay, and then for this thing, it's the same. Instead of using water, I use air. So can you see this rises the highest? This is the reverse. The pressure here is the lowest. Okay, pressure low, that's why the water can raise very high. Why? Because the velocity here is the highest. Okay, so sorry, not here, my mistake, it's here. Okay, the pressure here is lowest, the velocity here is highest. Okay, because it's at the end. Okay, so I want you to focus on this and this. Okay, this is the same thing as this, as the second one. Okay, can you see here is the highest because pressure is the lowest, velocity is the highest. This is the narrowest here. Okay, so the pressure here is highest. That's why the water can't go that high. Pressure is very high. So velocity here is the lowest. This is slowest here. Fastest at the middle. Okay, I hope you can understand. They won't ask you to explain much here. They might ask you to draw the water level. Okay, so simple. Okay, I hope you understand this. Okay, faster, pressure lower. Okay, faster, velocity higher, pressure lower. It's the reverse. Okay, so that's it. Okay, we have finished our chapter. I hope you still remember what we have learned in this chapter. Okay, we have learned displacement, velocity, engine first, engine, and then we learn displacement, velocity, and acceleration. We learn inertia, we learn momentum, and then we learn pressure. Okay, and then we learn Archimedes principle, we learn Bernoulli's principle. So there's a lot of things in this chapter. I might do a revision class next, okay, to refresh a little bit on this. Okay, so let's look at exercise. Okay, so that's the airplane. So what is J? J is thrust. Okay, K is lift, L is drag, M is weight. Okay, how is J produced? Okay, by the jet engine. Okay, explain your answer. Jet engine thus combustion, okay, propels plane forward. Okay, what is the relationship between K and M when aircraft flies horizontally? It means they go like that. Okay, when it flies horizontally, K and M, lift and weight, okay, they are the same. Okay, because I'm doing like this. If lift is higher, I'll go up. Weight is higher, I'll go down. So here, same. Both sides same. It's like two string, the same force. That's why it's not moving up and down. What is relationship between K and M when aircraft ascending? I'm going up. Okay, so let's use K and M. Okay, K is larger than M. Okay, what is the physics principle that causes force K? So this is called Bernoulli's principle. Okay, lower pressure, higher pressure, push it up, lift. Okay, explain the principle in E. Okay, in a fluid, okay, a region of high velocity, okay, experiences low pressure. Okay, so basically high velocity, low pressure. That's my keyword. Okay, so this is an aerofoil which has the lowest pressure. Lowest pressure means highest velocity. Fastest where? P. Okay, here. Which area has the highest velocity? Same thing lah, P. Explain how the area of low pressure stated in G is produced and lift up the wings of the plane. Okay, how do I generate the pressure here? Okay, so according to Bernoulli's principle, okay, according to Bernoulli's principle, velocity at P is highest. Okay, so pressure at P is lowest. Okay, so pressure, you can even say R, velocity at R is lowest, pressure highest. Okay, so it generates lift force. Okay, so try not to write too long. The aeroplane is flying with constant velocity at fixed altitude. Write down two mathematical equations to show how forces react on each other. Okay, so fixed altitude, not going up and down, means K equals to M. Okay, constant velocity means I'm not going faster forward or going slower. Means forward force and backward force is the same. So J is equal to L. Okay, forward equals to backward, upward equals to downward. Okay, simple. So name liquid P. So this is my fuel. P should be my oxygen. Okay, liquid oxygen to carry more oxygen. Name the fuel used in rockets. Sorry. Okay, this is hydrogen. Okay, you can say liquid hydrogen. Explain how the exhaust gas leaves thrusting the rocket upward. Okay, so you can say hydrogen and oxygen combust in combustion chamber. So exhaust gas leaves rocket at high speed. Okay, so according to conservation of momentum, okay, rocket is thrusted in opposite direction. Okay, or you can say upward. Okay, simple. So as the rocket goes up higher, acceleration increase. Give one reason. Because gravitational force decrease. Okay, the higher you go, the less gravity you experience. State one difference between rocket engine and jet engine. Okay, you can say fuel. Okay, or you can say atmosphere, one can work, atmosphere one cannot. Okay, so draw water level, you see. So lowest pressure should be here. So here. Okay, this is water one, not the air one. So the second is here. Okay, the highest pressure is here. Okay, because water is the slowest here. Okay, lowest pressure is Q, slowest water is P, highest pressure is P. Okay, this is the same thing. Fastest flow of water, this and this is the same. Lower pressure means fastest water means Q. This is the air one. Water level XYZ. So velocity is the highest here, pressure is the lowest here. Pressure low, water can go very high because not much gas pushing down. Okay, so second is here. Okay, because I start here, and then the highest pressure is here. Okay, pressure highest because velocity here is lowest. Okay, explain why the water rise up the vertical tube. Okay, and you can say pressure in the tube is lower than atmospheric pressure. Okay, this is your straw concept. You have atmospheric pressure pressing down. So imagine this is a straw. So you suck it up, no air here, atmospheric pressure will push it in. Okay, this is form 2 stuff lah. Okay, explain how Bernoulli's principle is applied to air flight. Okay, so in an aerofoil, please say aerofoil. Okay, upper region has high velocity, okay, low pressure, and then lower region has low velocity, high pressure. So generates lift force. Okay, how do you explain this answer? Bernoulli's principle. Name two apparatus that make use of this thing. Oh, interesting. Okay, what uses Bernoulli's principle? Actually, your Bunsen burner. Do you know that? Okay, how Bunsen burner works. Let's explain. Okay, this is your Bunsen burner. I have a gas tube coming in. So gas is coming at quick velocity. So velocity here is high. Pressure here is low. When I open an air hole here, pressure surrounding is high. I'll push it in. So a lot of oxygen going in, I will create a blue flame. So when you open the hole, you have blue flame. Okay, I'm sure you know this lah. Okay, so Bunsen burner. What else uses Bernoulli's? I think Bunsen burner. Yeah, I think that's Bunsen burner. Okay, so mark water level at B and C. So there's no up thinner or thicker tube, so just going down. Okay, give explanation in your answer. Okay, pressure is highest at A because velocity is lowest. Okay, so you can say followed by B and C. Okay, so one mark only, don't make it too long. Can you see all water level is the same? Okay, pressure doesn't care about what shape your container it is in. It only cares about the height. Okay, observe the water level in XYZ. Okay, give one conclusion based on the observation. Okay, pressure is only affected by height. Okay, not the shape of container. Alright, so compare the velocity. This is trick question. Can you see it's bigger here? So the velocity should be very low here, very slow here. Okay, so pressure should be highest here. Compare the velocity of air in region L and M. Okay, L is more than M. Well, we're talking about velocity here. L is faster. Compare the pressure. So M is larger than M. Okay, compared to U and V. So pressure here is high, water should be low. Pressure here is low, water should be high. So the water level of U should be more than V. Okay, that's it for this chapter. Thank you for paying attention. Not a very long video this week because this is the last part of it. Okay, hope you learned something new today. Okay, I hope you're paying attention. Watch it a few more times if you don't understand. Very simple concept. Alright, I'll see you again next week. We shall do a revision. Okay, till then, bye bye.